Hello everyone, welcome to Exemplar Physics. This is the third video in the series CBSE sample paper for the academic year 2020 and 21 for class 10 subject Science Theory, subject code 086. There are already two videos in this playlist. In the first video, we have discussed on the question paper pattern, and in the second video, we have discussed the questions of physics asked in the section A. In this video, we will be looking at the questions asked in section B. Before starting to solve the questions, there is a notification for the students. So this is the notification. So let's start our discussion. So the first question of physics in section B is question number 25. So there is a diagram, you can see the diagram of the prism. So I am drawing the diagram here. So we have a prism, question number 25. So this is the prism we have. And a white light enters the prism. So I am drawing white light with black color. Okay, so this is the white color which enters the prism. So after entering the prism, it undergoes a refraction, which we know. So it undergoes a refraction. And it gets split into different component colors. So violet, I don't have violet color, so I am drawing the violet color with blue. And again, on this surface, it undergoes furthermore refraction. So the colors undergo furthermore refraction. So this is the red part, and the below one is the violet part. So this is what given in the diagram. The diagram is not colorful, by the way. So white color enters a prism, it gets split into different colors. So there are band of colors between them. Okay, so there are band of colors between them. So let me also draw the green. Okay, so you know what are the colors there. So it starts from violet from the bottom. Okay, you know that. So we get a band of 7 colors, namely Vibgyor. Violet at the bottom, red at the top. So let's read the question. A student observes the above phenomena in the lab as a white light passes through the prism. Among many other colors, he observed the position of two colors, red and violet. What is the phenomena called? What is the reason for the violet light bend more than the red light? So we know the section B, each question consists of 2 marks. So this is a 2-mark question, and this question has 2 parts. So let's see. So first part is called, what is this phenomena called? The phenomena of splitting of white light into its band of 7 colors. What is this phenomena called? This phenomenon is called as dispersion. This phenomena is called as dispersion. So what is dispersion? You need not have to write the answer, just a dispersion. You have to write just a dispersion. The phenomena is called as dispersion. That is enough for the answer. So just for explanation, so what is dispersion? Dispersion is a splitting of white light into, splitting of white light into a band of 7 colors and we call this band as spectrum. Is called as dispersion. So the splitting of white light into a band of 7 colors is called as dispersion. Now the second part of the question, what is the reason for violet light bend more than the red light? If you see the figure, you see here the violet light bends more compared to red light. So what is the reason? So if you see the marking scheme of the paper which the CBSE has released, it has written that the speed of light is minimum, hence maximum deviation from its path. So that is the answer written in the marking scheme. But I don't think that's a best answer to this question. Actually, the thing is, the refractive index of a medium is inversely proportional to the square of the wavelength of the light. So if the wavelength of the medium is more, so the refractive index will be less. Conversely, if the wavelength of the medium is less, so refractive index is more. How this is going to affect here? If refractive index is more, this implies more bending of light when it falls obliquely at the boundary. So if the refractive index is more, it means more bending of light, so more deviation from the path. More bending, I mean to say more deviation from its path if the light falls obliquely to the boundary between the two surfaces. So like here, let me write the names of the side vertices of the prism A, B, C. So if you see, this outward medium is air, and what is the medium inside this? This is glass. So AB, if you see the surface AB is the boundary between air and the glass. So at the boundary of air and glass, refraction takes place. So light deviates from its path, straight path. So that light which is deviating from the straight path, how much it deviates, that depends upon the refractive index of the medium with respect to its surrounding. So here the refractive index of glass with respect to the air. Now if the refractive index is more, it implies that the bending of light or the deviation will be more. And this refractive index, though this is not in the syllabus of class 10th, but this is the fact. So this refractive index depends upon the square of the wavelength. Now if you see the white light, so the red has maximum wavelength and violet has minimum wavelength. So wavelength I am representing it by lambda. In class 9th, you must have studied about wavelength and frequency in the chapter sound. So red having the maximum wavelength in the visible spectrum of light, and violet being the minimum wavelength. So the refractive index will be maximum for which color? So refractive index is maximum for violet. So I'll write here mu is maximum. So if mu maximum, that means what? More bending. And for red, the refractive index is minimum. If the refractive index is minimum, this leads to what? This leads to less bending of light. Okay, less bending of light. I'll just mark like this. Less bending means less deviation from its path, and hence the violet bends more. It is very interesting phenomena. So You can also would be interested to know that since the refractive index is dependent upon the wavelength, every color has a different wavelength and hence a different refractive index. So the light of different colors bend through different angles on refraction. If the white light passes through a glass prism, the violet rays deviates the most and the red rays deviates the less. I hope you have understood the concept. At any point if you are facing any difficulty in understanding, please write it in the comment section. I'll surely help. So the next question, question number 26. So before moving to the next question, I'll just like to know that if you haven't seen the previous two videos, the links of the videos are given in the description section, or I'll keep it in the I button where you can click after watching this video. If you have any suggestions for the videos or the topics to be covered, you can write them in the comment section. Now let's get into question number 26. So in question number 26, again we have a diagram. So let's see the question number 26. So let me draw the diagram for you. After that we'll see the question.
So this is R1, 4 ohms, R2, 12 volt potential difference. That is it. High current entering.
So this is the diagram. So let's see the question there. A student has two resistors, 2 ohm and 3 ohm. So the student has two resistors. So one is 2 ohm, the other one is 3 ohm. She has put one of them in place of R2. So we have to place the resistors in place of R2. As shown in the circuit, the current she needs in the entire circuit is exactly 9 amperes. So the current she needs in the entire circuit, that is the current entering the circuit, should be 9 amperes. Show by calculation which of the two resistors should be chosen. So which of the two resistors we need to choose? Is it 2 ohms? Or is it 3 ohms, so that the current entering the circuit is 9 amperes. So I hope you have understood the question. Now how to attack the question. So for that let us use Ohm's law, right? So Ohm's law says that V is equal to IR. So this is the formula. Now let's see bit by bit how to solve this question. Now if you see here, the 12 volt, the potential difference across, let me name this, let this be A and this be B. So the potential difference across AB, so I am writing it as VAB. VAB is how much? The potential difference across AB is 12 volts. So what is potential difference across R1 and what is potential difference across R2? The potential difference across, see the figure, the potential difference across AB, if you see there, and the potential difference across R1, both are same. So what is the connection between R1 and R2? So the connection between R1 and R2 is parallel connection. So this is a parallel connection. So if it's a parallel connection, the potential difference between R1 and R2 will be the same, and that is same as the potential difference between A and B. So how much is that? That is 12 volts. If the potential difference across R1 is 12 volts, so what is the current entering R1? So what is the current entering R1? So from this relation, I is equal to V by R. So potential difference is 12 and the resistance is 4. So R is R1. So how much is that? 3 amperes. So the the current flowing through R1 is 3 amperes. So what is the current flowing through this branch? So total current has to be 9 amperes. So the current passing through this branch will be 9 minus 3, which is 6 amperes. If 6 amperes current flows through this, what should be the potential difference across R2? That should be same as R1. How much is at R1? That is 12 volts. If that is so, then what is the value of R2? So from the same formula, we can find resistance is equal to V by I. So resistance, which resistance do we want? We want R2. So what is the potential difference? 12 volts. What is the current? 6 amperes. So what is the resistance? The resistance has to be 2 amperes. Sorry, 2 ohms. The resistance has to be 2 ohms. Clear? So that's your question number 26. So in section B, we have only 2 questions. Each question consists of 2 marks. So this is also 2 mark question. So I hope you have learned something in this video. If you have, then please like the video and share with your friends and family members. I'll be in front of you again with the questions of physics in section C in the next video. Till then, bye bye.